Hello, Pre-P Chemistry. How are we doing today? Hopefully y'all are doing well. Mr. Oglesby here. Today we're going to be going over Unit 9, the very last lesson in Unit 9, which is going to be over redox reactions. So let's go ahead and dive on into it. So first off, what is redox? Well, redox is basically a shortened way of saying reduction and oxidation reactions. And so basically all that is saying is that in a reaction, we have electrons that are gained or lost. Electrons are going to move from one atom to another atom or from one ion to another ion. And so reduction and oxidation is basically talking about how those electrons are going to be moving. Now, for this lesson, you do need to know the difference between oxidation and reduction. So for that, there's two different sayings that you can say. The first off is oil rig. So oil rig is basically going to be oxidation is losing, reduction is gaining. I'll go over it in a second. The other is Leo the lion goes grrr. So for that, that's the loss of electrons is oxidation, and the gaining of electrons is reduction. Okay, so they say the same thing, but they say it in slightly different ways. What it comes down to is when we talk about oxidation, we talk about electrons being lost. And when we talk about reduction, we talk about them being gained. Okay? So I'm actually going to look at these a little bit closer so that we can actually write this out. So for oil rig, we say oxidation is losing electrons and reduction is gaining electrons. Okay, so oxidation is losing electrons, reduction is gaining electrons. This is my personal preference on how I've always remembered redox reactions. Okay. The other, Leo the lion goes grrr, right? So the loss of electrons is oxidation, and the gain of electrons is reduction. But again, they're basically just the same thing, just saying it in a little bit different way. Whatever relates to you the most, choose that as a way to remember what the difference between oxidation and reduction actually is. Okay? All right, so what is going on in oxidation and reduction? Well, we know that it's a gaining or losing of electrons. So let's go through your rules for oxidation numbers, okay? And what we're doing with this is basically determining what the oxidation number is for each element that's there, okay? So rule number 1 says the oxidation number in a compound will add up to 0. So basically, while we're trying to find our oxidation numbers, if it's a compound, we want it to equal 0, okay? Kind of like an ionic compound, right? When we swap, drop, reduce, basically what we're doing is we're canceling out those charges until they add up to 0, okay? Rule number 2 says the oxidation number of an ion will add up to the charge of that ion. So if I'm talking about something like phosphate, phosphate has a -3 charge. So when I add the phosphorus oxidation number and the oxygen oxidation number together, then they should add up to -3. Okay? Rule number 3 says an element not in a compound, which is basically by itself, just the element, it has an oxidation number of 0. For example, if I've got oxygen or silver or potassium or calcium, those are all going to be 0 for their oxidation numbers. Okay, so it doesn't matter if it's a diatomic. If it's just that element, then its oxidation number is 0. Rule number 4 says that if I'm in an ionic compound, the oxidation number of groups 1 through 3 and 13 through 18, they are equal to their charge. So if I've got calcium and chloride, so calcium chloride, calcium has a +2, chlorine has a -1. Okay, calcium is in group 2, so it's everything in group 2 has a +2 charge, and chlorine has a -1 because everything in group 17 has that -1 charge. Now, again, that's only with ionic compounds. Covalent compounds are the ones that you're going to have to remember a couple of rules that are in addition to everything else we've done. Okay, so in a covalent compound, the element closest to the top right of the periodic table, so closest to fluorine, has an oxidation number that is equal to the charge of that ion. Okay, so if I'm talking about fluorine or oxygen, whatever is closest to that top right corner, it's equal to its charge. Okay, so essentially I would say, okay, well, oxygen has a -2 charge. Fluorine has a -1 charge. Chlorine has a -1 charge. Okay, and so when we're looking at that, that's what we're looking at, is we're trying to figure out what is closest to that top right corner, because that's going to be the thing that we're basing everything else off of. Now, hydrogen is always a +1, okay? Now, the only time that if I've got oxygen, the only time oxygen won't be a -2 is if it's in what we call hydrogen peroxide. And so that will mean that it's going to have a -1 instead of a -2. Okay. So, rule number 6 says the oxidation number of oxygen is always a -2. Again, unless it's in that peroxide, right? Because then it would be a -1. The oxidation number rule number 7 says the oxidation number for hydrogen is a +1 unless it's combined with a metal to form a hydride, and then it's a -1. Okay, so the example for that, we don't tend to actually use them much in this class, but if it's forming a bond with a metal, so magnesium hydride or something like that, then you would have that hydrogen with a negative charge instead of positive. Okay. And then rule number 8 says fluorine always has a -1. And the reason is because it is the most electronegative, right? And we know that electronegativity is that tendency to attract an electron, right? So it's going to be the most likely to pull an electron towards it, giving that transfer of electrons towards it, making that negative charge happen. Okay. So let's actually go through and use these. So what they've asked us to do is determine the oxidation numbers for each of these compounds. So I'm going to go ahead and start with NO. Okay, so with NO, first off, this is a compound, right? Well, we know that the overall oxidation number, when I add everything up, because it's a compound, it should all add up to 0. Okay. Next, we need to find the oxidation number for each individual element. So I don't know nitrogen, but I do know oxygen is always a -2 unless it's in hydrogen peroxide. Then it's a -1. So looking at this, I have 1 oxygen. So I have a total of -2 coming from my oxygen, right? And I want this to equal 0. So I'm going to need a +2 coming from nitrogen. There's only 1 nitrogen present, so that 1 nitrogen has to give me a +2. So the oxidation number for nitrogen is +2, and for oxygen is -2. So nitrogen equals +2, oxygen equals -2. Okay? So let's take a look at another one. So here I've got PCl3. Okay, so looking at this, how do I figure out what is going to be the oxidation numbers? Because I don't have any rules. Well, I see, okay, which is closest to the top right corner of the periodic table? Chlorine is, right? So we're going to use the charge for chlorine, which is -1. So the oxidation number for chlorine is -1, okay? Now, I do have 3 chlorine present, so 3 times -1 gives me a total of -3, and I want this to equal 0, so I'm going to need +3 to cancel that out. I have 1 phosphorus there, so 1 times what oxidation number will give me +3? Well, that's +3. So phosphorus has a +3 as its oxidation number, and chlorine has a -1 as its oxidation number. Okay? So now I want y'all to pause your video and do these next 2 problems. Now, for this, actually, let's just go ahead. I want you to do just the CCl4, okay? So I want y'all to pause your video, solve CCl4, find the oxidation numbers, and then restart it, and we will go over it, all right? Okay, so what you should have found is that carbon has a positive 4 and chlorine has a negative 1. Okay, I just looked on my periodic table and I found that chlorine is closest to that top right corner, so it's going to have its charge, which is negative 1 for everything in group 17. You've got 4 of those, so 4 times negative 1 gave me negative 4. Want it to equal 0, so I need a positive 4 to cancel that out. There's only one carbon. 1 times what charge, what oxidation number will give me that positive 4? Positive 4. Okay. All right. So now let's take a look at this one. So this one's a little bit different because this time we've got 3 different elements that we're working with. And so what I'm going to need to do is think about which things that I actually know. Okay. So I know oxygen has a negative 2. Okay. Well, I also know that this is lithium, but this whole thing right here, that's a polyatomic ion. So what do I do with that? Well, anytime we've got a polyatomic ion here, what I'm going to actually have to do is separate this out into its parts. So I'm going to keep lithium off to the side, and then I've got MnO4, and I know that MnO4 has a negative 1 charge. So I know oxygen's oxidation number is negative 2. So I have a total of negative 8 coming from oxygen, right? Well, I want this to equal negative 1. So what do I need? Well, I'm going to need a positive 7 to cancel that out, right? Which means I need my manganese to give me a positive 7 for its oxidation number. So I'm going to erase that real quick. So I know that manganese has a positive 7. So I have 4 times negative 2. That gave me a total of negative 8. I have 1 times positive 7. That gave me a total of positive 7. This overall compound I want to equal 0. Well, how do I do that? Well, I need plus 1 more. So that means my lithium has to be giving me a positive 1. So the oxidation number for lithium is positive 1. For manganese is positive 7. And for oxygen, it is negative 2. Okay? All right. So I want y'all to solve this one more problem real quick. Pause your video, solve it, and then check your answer directly after you finish. So resume the video. I'm going to quickly show you the answers, and then we're going to go ahead and move on. All right? Okay, so this is what y'all should have ended up with. So you should have found that phosphorus was positive 3 and oxygen was negative 2. Ultimately, the big thing to remember for this one is that I do have a charge here for this ion. And so when I'm adding everything up, it should equal that charge. Okay? All right. So now let's take a look at oxidation numbers in a reaction. So we know that oxidation and reduction is about gaining and losing electrons. Now, typically when we talk about these, this is going to be throughout a reaction rather than just looking at it in a individual compound. Okay? Now, how do I do this? Well, essentially what I'm doing is I'm looking at an element and I'm trying to decide throughout the reaction, did it become more positive or did it become more negative? If it became more positive, then it lost electrons, right? Which means it is oxidation. If it became more negative, then it gained electrons, so it was reduced. So here's what we do. So here it says write the complete balanced equation for this. So the very first thing that I need to do is write this. This is a synthesis reaction. So I have Al and then O. And then I would need to cancel out my charges. Aluminum is a plus 3. Oxygen is a minus 2. So looking at this, to cancel that out, I'm going to need Al2O3. Then I would balance. This would be a 4, a 3, and a 2 to balance that. Well, now what I need to do is I need to find the oxidation numbers for everything in this. Well, we already know that if it's an ionic compound, the oxidation numbers equal their charge. So the oxidation number for aluminum and oxygen are already written there for you. Now over here, we also need to know these oxidation numbers. So right here, I've got aluminum. Aluminum is an element. It's in its what we call free state, which means it's not bonded with anything. Well, if it's not bonded with anything, it hasn't gained or lost any electrons, so its oxidation state is 0. Here, oxygen, O2, it's not really bonded with anything either. So again, its oxidation state is 0. Okay, so what do I do with that? Well, essentially what I'm going to do is I'm going to look and see how did these change throughout the reaction. So aluminum went from 0 to positive 3, and oxygen went from 0 to negative 2. So aluminum, it went from 0 to positive 3, and oxygen, it went from 0 to negative 2. Okay, well, looking at these, I need to know what was oxidized and what was reduced. And I know that if my numbers changed, then something was oxidized and something was reduced. So my numbers did change. Aluminum went up, oxygen went down. Okay, so I like to think of this as, well, oxygen went down, and if I were at a store and I watched the price go down, I would say the price was reduced. And so the same thing is happening here. Here I went from 0 to negative 2, it went down, so the oxygen in this case was reduced. And the aluminum was oxidized. So basically you're just looking at the reaction and saying, okay, well, oxygen went down, aluminum went up. Down means reduced, up means oxidized. Okay? So let's do another one. I want y'all to go ahead and give this one a try. It's very similar to what we just did. So give this a try, see what happens. So pause your video and then we'll go over it. All right, so here is what you should have ended up with. So what I found was that iron in its free state has an oxidation number of 0. Sulfur in its free state also has an oxidation number of 0. Over here, one thing that I did do is I found that sulfur has a negative 2 because of where it is on the periodic table. But I personally also know that iron, a common ion of iron, is positive 2. And so that's what I used here. Technically, it could have been positive 1 or it could have been positive 3, but we know that iron is typically a positive 2, and so that's what I used for this, okay? Now, you'll be given the formula in that case, or you'll be given the Roman numeral for it, so do keep that in mind, okay? So I have iron, and it went from 0 to positive 2, and then I have sulfur, it went from 0 to negative 2. So sulfur went down, so it was reduced. Iron went up, so it was oxidized. Okay. Alrighty, so I'm going to do one more problem here. And the reason I want to do this is because this time we've got more than 2 elements. And so I want to work through one of these with you, and then we will be done for the day. All right, so here I've got to look at each individual compound / element in this, and I want to make sure I know all my oxidation numbers. Okay, so I know that I've got sulfur. Sulfur is a negative 2. This is an ionic compound, right? And so since it's ionic, we just use our charges. So sulfur is a negative 2. Hydrogen is a positive 1. Right here with chlorine, chlorine is in its free state, so it's a 0. Sulfur is in its free state, so it's 0. And then here, hydrogen is a positive 1 and chlorine is a negative 1. So let's see what happened. Hydrogen went from positive 1 to positive 1. Sulfur went from negative 2 to 0. And chlorine went from 0 to negative 1. So hydrogen, it went from positive 1 to positive 1. Did it change? No, it did not. So don't worry about it. Equals 0 change, nothing happened. It is not oxidized, it is not reduced. Sulfur went from negative 2 to 0. Well, what happened? That number went up, right? And so that would tell us that it was oxidized. And then chlorine went from 0 to negative 1. Well, it went down, so it was reduced. Okay, y'all, if you find one thing oxidized, you should also find one thing reduced. Okay. All right. And then the very last thing, it did ask you to balance this equation. So to balance this, we would just put a 2 right there, and that would be it. So that is it for our notes over Unit 9. I know it was a big unit. I know it covered a lot of stuff, but hopefully y'all understand redox reactions. Let us know if you've got any questions, but otherwise y'all have a great rest of the day. Bye, y'all.